Hello once again, and welcome to Learn Python 3 the Hard Way, exercise 42. This exercise is where things get really weird. If you went to college and you ever took a philosophy class, you might run into similar wording, I believe in epistemology, and definitely if you ever studied Plato. However, most of the belief in that style of I don't know how to say it, perception. The idea that things can be classified and that they inherit from things has kind of totally been debunked. So this is a holdover from when people in computing believed that being able to classify things was a big deal. Now we know that this isn't necessary. So what I'm saying this for is to understand that this is a manufactured construct. Okay, it's like money. In a lot of ways, I'm going to pull up the code. The idea that we can say class animal or class dog is a type of animal and class cat is a type of animal really doesn't work in the real world at all. Like if you try to go and say, look at a computer, right? You can't say like an IBM 360 inherits from an ENIAC, which are two old computers. They don't inherit. It's not really like an inheriting thing. In the world of, say, animals like this, okay, this really is just the kingdom phylum system. But even that we sort of found out was just arbitrary. We just picked two things that look the same and said they must be related. Now we know that that's not really true. Genetics shows that it isn't. They might not be related just because they look the same. So the thing to understand when you read this, when you try to learn this, is don't feel bad if it makes zero sense, because it is completely contrary to how the actual real world works. The real world works more by composition and assembly, okay? Even you inherit things from your parents. You are an assemblage of DNA sequences from your parents. You're not really a new class of person. You're not a new object or instance of person. You are a assemblage of parts from two other people, and your assemblage is actually not perfect, so that way you're a unique person. So this whole classification system is completely manufactured just for humans to try to understand how to classify the things around them. And for the most part, it's not really valid anymore. We understand that this isn't really how classification should work. So that's my pitch as to why this is the thing you learn just because everyone else in programming thinks you should learn it and they use it a lot. It has no real truth. Like I said, it's like money. Just because you have a green dollar bill or a purple dollar bill or whatever country you live in and their color of dollar bill doesn't mean that that thing is actually worth how much is on it. It's just everyone agrees. Everyone sort of manufactured a truth that that money is worth something. So same with object-oriented programming. It works because everyone sort of agrees that's how it should work. In theory, if computing had gone a different direction, this might not even exist. In the same way that if money had gone in a different direction, it may not have even existed. Okay, so how do you do this exercise? Well, first off, you need to read this text. I'm not going to get into the text because the text explains pretty well what's going on. One thing I will talk about is when you come down at the end, I talk about the whole class object thing. So in old Python 2 code, you used to have two different kinds of classes, right? If you did this, it was different than if you did this. Okay, and now in Python 3, they fixed it so that the two are exactly the same. However, it's debatable which of these forms people should use. Okay, so while I was writing the book, I just kept adding it because I was just used to it because I'd done Python 2 code. So then I thought that was a mistake and I asked around, and a whole bunch of people who also write Python books are saying, no, we include object because Python has sort of this list of aesthetic rules they call Python Zen, and one of them is explicit is better than implicit. So saying that something inherits from object is explicit. You are saying, I definitely am making a thing from object. That's fine. It's mostly documentation, to be honest. So go ahead and do it the way I'm showing you. But if you ever go work somewhere or code somewhere and they don't do that, they do this, then do what they're doing. Okay. And if one day the winds of programmer fashion shift to where doing code like this with object suddenly makes you a stupid programmer or a bad person, then stop doing it. Trust me, that does happen. Now, let's look at this code. You should know that pass is a way for you to basically do that without the Python interpreter kind of complaining. So all you're doing is you're saying, yeah, this class has nothing. And sometimes people will do it that way. Okay. So once you have that, you're supposed to write comments above each one that explain it. Now, this is basically an applied phrase drill. Okay. You're saying animal is an object. See, it's kind of confusing. So this is why I think that in Python 3, they should have ditched object entirely. And instead, they should have just made everyone do this. In the same way that they got rid of print not having parentheses, they should have said, nope, no more object. But I guess they didn't. So now we say animal is an object. And that's fine. We're basically saying it's a basic thing. Okay. Now, dog is an animal. So that would be where you'd write that. And then you would say init takes self and name. And dog has an attribute named name. Okay, so you would go dog has a attribute named name. Okay, what's the significance of this? Like, what's the purpose of this? It's more about learning how to speak object, but also about solidifying the idea of where things should go and where they come from. Frequently, people confuse the concept of having a thing, right? Like a car has wheels, with inheriting a feature from something. So you would say, instead of doing a car has wheels, you would say a car inherits from a thing with wheels. And that's sort of like a big issue with the way objects are inherited. For example, I will concrete this for you. If I had class car, and I could do object, and then I could do def init self, and I could say self.wheels equals 4. I could do something like that. Okay. This is has a. Well, cars have 4 wheels, right? It's composition. I can create a car that has different systems, and there you go. It doesn't really have to inherit from a car with 4 wheels. But some people will do it this way. They will say 4-wheel vehicle. And then you don't have this. Okay. This is kind of an aesthetic difference, but in this case, what you'll then run into is then they will have a class for 2-wheel vehicles, for 8-wheel vehicles, for 16-wheel vehicles. They'll have all these classes that basically just enumerate all the possible wheels. It's better to say cars, when you design like the data for them, have certain numbers of wheels. When you get to making databases, the significance is, if I have to make a class for every number of wheels of cars, I have to make a database table for every number of wheels of cars. So once you start making databases, you start to figure out, oh yeah, I shouldn't do this. So this exercise is about teaching you where things go. Is it the difference between this is a thing? Like these are attributes and concepts about that thing that are inheritable. Or is it something that they have? It has 4 wheels. It has a dog collar. It has an owner. Okay. That would be another good example. If I create an animal, right, I can say, I can do def init self owner, right? And I can say owner, self.owner equals owner. Okay, that is using has a, its composition. You're saying animals can be assigned an owner. Okay, what some people do in object-oriented that I say is a mistake is they would go in and they would say owned creature. And then they would get rid of this and they would create class owned creature. And then they would put that there. That's another example of not knowing the difference between animals have a owner versus animals inherit from things that can have owners, right? That doesn't work because what happens if you have multiple owners? What happens if you want to add lots of attributes, fur color, things like that? Are you going to inherit from every fur color? Are you going to inherit from things with fur? Eventually, you get this huge long list of classes like furry, species, blue-eyed, right? Those are attributes that are assigned to it that you can put on there, and you don't have to inherit to do them. Okay. Now, we can get more into that later, but for now, just go through this exercise and focus on, does the thing have that attribute, or does the thing inherit the attribute from something else? And when you're done, it might be good to make your own class of things, maybe using humans or something like that. Try to come up with your own classifications of things and solve each of these. All right. Okay, that's the end of that exercise. Again, I'm going to warn you that object-oriented programming and the concepts are super weird. It's one of these things that you just kind of don't get. It's like English grammar. The only way you know that I'm supposed to say big red ball instead of red big ball is because I grew up speaking English. I'm sure there's rules. I know that everyone always writes down rules, but English is just weird. And you just have to know it. That's it. You don't have to do anything other than know it. Memorize it. So when object-oriented programming is kind of the same way. This is weirdly invented language that everyone kind of knows, and if you don't speak it right, they know you don't know it, and it's all about just learning how to speak it and what the concepts are. In this case, where are things? Is it something you inherit? Is it something you have? That's it. Okay, see you at the next exercise.